So in this screencast, I just want to go through some of the surd rules and some of the stuff we've done so far. We've missed a few lessons, so I'm a bit concerned about our progress. So I just want to check out how we're going with surds. So I'm going to pose a few questions here. I'm going to put this into a TEDx, a TED-Ed platform, and I'm going to get some multiple choice questions happening, and I'd like you to take part in that. So this is on simplifying surds. So I just want to check that we're okay with this concept of how we simplify surds, simplifying surds. So what we're trying to do, remember, is we're trying to find a factor of the surd, of the number that's under the square root sign. So for example, we're trying to find, so if we're looking at, say, 18, square root of 18, we're trying to find a number that goes into 18 that's a square number. So you need to be really cool with the square numbers. So the square numbers are the numbers that are the result of squaring a number. So 1 squared, right? 1 squared, that's 1. So our first square number is 1. 2 squared is 4. So these are the square numbers here. 1, 4, and it goes on. You know, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100, 11 squared is 121, 12 squared is 144, 13 squared is 169, 14 squared I think is 196, 15 squared I think is 225. We're getting big now, but really it's the first, let's say certainly up to 12 times 12, you know, that's where you're going to sort of be expected to know and have a working knowledge of them, so you're not scratching your head too long trying to figure it out. Square root of 18, any of these numbers go into 18? 1, 4, 9, oh yeah, 9. So what we do is, without taking shortcuts, we just say that this is equal to the square root of 9 times the square root of 2, because it is. We can split a surd up like that, it's okay. Remember that the square root of, I'll convince you of this, square root of 9 times the square root of 4, you know the square root of 9 is 3, and you know the square root of 4 is 2, so that's actually equal to 6. And if you multiply 9 and 4 together, you get 36, and you know that they're equal. And so you know that you can split 36 up into its factors 9 and 4, and it's still okay to do that. So this is our rationale for doing this. And what it enables us to do is it enables us to write the square root of 9 as 3, we drop this multiplication sign, and we write 3 root 2. We drop the multiplication sign, just like in algebra when we say 3 times m, we don't worry about the multiplication sign, do we? We just write 3m. It's the same thing here. Root 9 times root 2, 3 root 2, and that's how we say it, 3 root 2, 3 root 2. That's how we say it, just to get things rolling. Okay, square factor, really important that we identify what that is. And we simplify simply by making this number here smaller, and as small as it can be. When it doesn't have any square factors anymore, right, when it doesn't have any square factors, it's simplified fully. So if the answer to that is, if it's yes, then what we're going to do is keep simplifying. If it's no, then it is fully simplified. Okay, does that have any square factors? So let's have a look at some examples. Let's simplify the following. So let's say square root of 48. Alright, so this is question 1. Square root of 48. Now, is there a number here that goes into 48 that's square? Alright, I'm thinking 12 fours of 48, so I could use that. But if I want to use is there a larger square factor of 48? 16. I happen to know that 16 threes are 48. But let's say I didn't know that, and I just went straight to 4. That's no worries. I just say, well, that's equal to the square root of 4 times the square root of 12, because 4 12s are 48. Alright, now, the square root of 4 is 2. And I drop the times sign, and I just go 2 root 12. Remember, alright, square factors, is it a yes? Is there a yes or a no to the answer to the question, does that have any square factors? Because if I stop there, I've sort of simplified, but I haven't simplified it fully. For example, if I said simplify 50 over 100, and you said, well, that's equal to 25 over 50, yes, you've simplified, but have you simplified completely? No, you have not. You've got to keep going until you've simplified completely. This 12 does have a square factor, and that is 4. So I'm going to take it to 2 times the square root of 4 times the square root of 3, because 4 threes are 12. Now that 4 there becomes a 2. So it's now 2 times 2 times the square root of 3. Notice I put the times back in there just to make it clear what I was doing. 2 times 2 is 4. Now when I'm simplifying, I'll drop that times. It's just 4 root 3 as my simplified answer. Okay, let's have a look at question 2, which is simplify 3 square root 28. So I want you to understand that this 3 is just 3 times this, and it's not going to worry me. All I'm going to do is work on my 28. Does the 28 have a square factor? Let's have a look at my list again. 4 times 7. I know 4 sevens are 28. Alright, 4 times 7. Look at that. 3 times the square root of 4 is 2. Times the square root of 7 is just the square root of 7. 3 2's are 6. That's the final stage of my simplification. Drop the multiplication sign. 6 root 7 is my answer. Okay, the 3 just holds out the front, multiplies by your simplified surd. Okay, let's have a look at the third question. It's going to be a fraction. Simplify this, the square root of 20 over 6. Okay, what should we do here? Let's look to simplify this 20. Can I write the 20 as a product of? 4 is going to come into play again, isn't it here? 4 5s. Alright, over 6. 6 we're not doing anything with, it's not a surd. That becomes 2 square root 5 over 6. And then our last move here is just to acknowledge that 2 and 6 have a common factor of 2. So I divide by that common factor, I get 3 and 1. Now obviously that 1 doesn't stay. We don't write 1 root 5, we just write root 5 over 3, and we've simplified. Alright, 2 more questions. Question 4. Let's have a look at square root of, let's have a whole square rooty thing. So square root of 18 over 27. Okay, what's that equal to? Well, it simplifies, but I'm going to use this surd property that, just like we can do with multiplication, we can split a fraction up into 2 separate surds. So I don't know why I wrote 19 there. My apologies. That should be a 27. 18 over 27 like that. Then I'm going to work on each surd. So root 18 is root 9 times root 2, using 9 as my square factor. Root 27 has also got root 9. Sorry, it's got 9 as a factor. So I end up with 3 root 2 on top, 3 root 3 underneath. My 3's cancel, and I just end up with the square root of 2 over the square root of 3, which I could write if I was so wanted to as 2/3. And you can see here that this actually, dividing by 9, becomes the square root of 2/3. So I could have gone through either way, but what we're trying to do here is I'm just trying to demonstrate I can split that fraction up. And the last one I want to do is I want to have a look at, I want you to unsimplify. Because sometimes this is useful. Just when you think you've got simplifying worked out, I'm going to ask you to unsimplify. Unsimplify 2 root 3. So what that means is, I mean write as a single surd. Write as a single surd. So what that means, alright, so unsimplify. So 2 root 3, we're going to write that as 2 as a square root is the square root of 4, square root of 3, leave as the square root of 3. So these are equal, but I want to write it as a single surd, which means I'm going back the other way. 4 3's are 12, and there's my single surd, root 12. It's unsimplified, but that's what we were asked to do, so that's all right. Now I'm going to attach a little multi-choice to this, so I want you to do that through the TEDx, through the TED platform. We're going to then move from here into exercise 3B, which is addition and subtraction, and I'd like you to view my YouTube on that, please. Addition and subtraction of surds. Excuse me. And while I'm talking to you, what that will involve, just like with algebra, when you're looking for like terms, 2x plus 3x is 5x. With surds, we add like surds. So 2 root 2 plus 3 root 2 is 5 root 2. See, my like terms here were x and x, so we just count it up. 2 plus 3 is 5. My like surds here are root 2, so I count them up. 2 plus 3 is 5 root 2. The only trick is if I've got, say, root 8 plus root 2, is not to discard the fact that, well, they're not like surds, so I can't add them, right? I don't know if they're like surds until I've simplified them. So root 8, oh yeah, hang on, I can write root 8 as root 4 times root 2. Alright, that root 2 I can't simplify, but this root 4 becomes 2 root 2. Oh, hang on a sec, look at that. I do have like surds. I do have like surds. 2 root 2 plus root 2 is 3 root 2. So I've simplified root 8 plus root 2 to that. I have like surds, and I know that when I simplify. If I have root 2 plus root 3, however, no, I can't simplify either. Not like surds, I can't simplify. Right, that's exercise 3b. I've made a YouTube for that. I'd like you to watch that, please, and then start on exercise 3b. We've lost a bit of class time, so I'd like you to do some work outside of class on that. Okay, I'll see you soon.